Hi, so today in this video I'm going to be talking about interval notation. Basically what interval notation is that it's saying for domain, it's saying this is all of the values that are x, all of our x values on this graph. And for range it's going to say all of our y values that are on this graph. Let's just hop into this example. We've got a parabola here, and we know that we can see that there's two arrows, which means that it's going on for infinity. It's never stopping. So when we are writing out in interval notation, we want the smallest value to the largest value. So when we're talking about domain, we want the smallest x value. In this case, it goes on to negative infinity. It's always going to be going to the left. It doesn't look like it's going to stop. So negative infinity, and we're going to do a parenthesis, because when we're talking about interval notation, the parenthesis means that it's not included, and the bracket means that it is included. And by not included, when we have infinity, we can never reach infinity. It's not technically a number. It's like the, it's always getting bigger, always getting bigger. So we can't technically include it, because if you included it, then there's always one bigger number than that, or infinity bigger number, like infinitely more numbers that are bigger than that. So what we will want to do is whenever you have an infinity sign, you're always going to put that in parentheses. And then it looks like we're always getting bigger to the right as well, so we'll do positive infinity, and we'll do a normal parentheses for that as well. For range, that's our y values. It looks like our smallest value on this graph is going to be this -1 right here, this point right here. So it looks like, and that's included, because technically you won't always see a dot like this, but if a line is there, it's part of it. So it'll be -1, and then it looks like it goes on to positive infinity. It looks like it always is going upwards. But what happens if you have something like this, where it's got some asymptotes and some holes, and it's got two pieces, or three technically? Some things that we can do is, or at least for tricky problems like this, it's good to identify pieces that we've got. So we've got this piece, we've got this piece, but then we have a hole, and then we've got this piece. And we've got three pieces here, so we're going to have three pieces in our interval notation. So starting with domain, our smallest point is negative infinity, because we've got that arrow going on forever. Then it gets super duper close to this +1, but it never touches that +1. So we'll do +1, and then it's not included because it's not touching ever. Basically, you'll do parentheses whenever it's going to infinity, so like you see an arrow, when there's an asymptote, so like a dotted line, or when there's a hole. I can't really think of any other times when you would be using the not included. I don't want to say that's the only times that it will be, but I'm pretty sure that's the only times that it will be in this class. Then, that's just this point, right? We also have like our two other pieces. So we're going to say U. That stands for union. And it's basically saying, so we've got all the values in this piece, and we've got all the values in this piece. Hold on, wait. Yeah. So, and we've got all the values in this piece, which it looks like it starts back up at 1, and then it looks like it has a hole at +2. So we'll end there, and that's not included also because it's a hole. That's a place where our graph doesn't touch. And then we also have this section, so and 2 to positive infinity, because then it goes forever. Yeah. So, and then for range, we're talking about all of the y values. So it looks like, again, we're going to start with our smallest, so negative infinity. It looks like it stops at about 0, and it starts back up, so and. So we've got this piece, we've got kind of this piece, and then we've got this piece. And then we'll have 2, 0, and then it looks like it stops at 1. So we'll do 1, and then 1, 2, positive infinity. Basically what it's asking is, what are all of the values for our y's? And then for domain, what are all of our values for our x's? Hopefully that makes sense. If you have any further questions, please let me know, and I will answer as soon as I can. Have a good one.